my channel. Welcome to another episode of I Wonder, and in this episode I'm going to talk about Industry 4.0. So without wasting any more time, let's start. Now, before moving on to Industry 4.0, let's talk about Industry 1.0, then Industry 2.0, then Industry 3.0, and then Industry 4.0. So, Industry 1.0 was the introduction of steam power and water power. Then came Industry 2.0, and Industry 2.0 was the introduction of mass production, assembly line, and electricity. After that came Industry 3.0, where the computer systems and robotics was introduced. And now it's time for Industry 4.0, where we are introducing automation in every aspect of manufacturing. What is basically Industry 4.0? Industry 4.0 is the name given to the current and the fourth industrial revolution. Now, Industry 4.0 aims at introduction of automation in various manufacturing technologies. It includes cyber physical systems, cloud computing, Internet of Things, and many other aspects of automation in various manufacturing technologies. Now, let's look at the design principles of 4.0. Now, there are four basic design principles in Industry 4.0. The first one is interconnection. Now, interconnection is the ability of the machines, the devices, sensors, and people to connect and communicate with each other via Internet of Things. The second one is information transparency. The transparency afforded by Industry 4.0 technology provides the operators with vast amount of useful information needed to make appropriate decisions. Then comes technical assistance. First, the ability of assistance systems to support humans by aggregating and visualizing information comprehensively for making informed decisions and solving urgent problems on short notice. Then comes the decentralized decisions. The ability of cyber physical systems to make decisions on their own and to perform their tasks as autonomously as possible. Now, let's talk about the requirements to implement Industry 4.0 in the full-fledged. Now, the capabilities or the requirements are divided into modules. The first module comes is Internet of Things. Under Internet of Things, the basic requirements are ability to connect and manage devices, real-time data collection, insights of what is happening, and new business models. Then the module that comes is flexible manufacturing. Now, under flexible manufacturing, the requirements are flexible machines, 3D printing, then machine-to-machine standards and protocols. After that comes autonomous systems. Under autonomous systems, the requirements are smart network of products, ability to communicate through the internet, and self-diagnose or self-awareness. Then comes Internet of Services. Under Internet of Services, the requirements are API economy, vertical or horizontal integration across value chains, and new delivery channels and business models. Finally comes analytics and cognitive. Under analytics and cognitive, the requirements are embedded equipments, products and services, predict what may happen, prescribe actions for best outcomes, self-learning, and communicate in natural language. Now, one of the most important topics related to Industry 4.0 is Big Data Analytics. So, what is the role of Big Data Analytics in Industry 4.0? Now, Industry 4.0 has a great impact of Big Data Analytics. Big data analytics consists of the 6 C's in the integrated industry 4.0 and the cyber physical systems environment. Now the 6C system comprises of connection, including sensor and networks, then cloud, including computing and data on demand, then we have cyber, that is model and memory, then we have content or context, then we have community, and finally we have customization. So these are the 6 C's which are directly related to the integrated industry 4.0 and the cyber physical systems. Now let's talk about the applications of industry 4.0 in the real world. So the first application of industry 4.0 is condition monitoring, including real-time status of process steps parameters. Then product shadow, including tracking of a product production cycle. Then we have digital assistant system, where digital work instruction for operators will be provided. Then we have digital performance management, where digital KPI boards with enabled problem solving will be present. We have then AGV in logistics, that is automated material supply. We have real-time tracking of stocks. Then we have advanced analytics for breakdown prevention, self-adjusting workstations, human-robot collaboration, tailored production components, and advanced analytics for yield, energy, and throughput. So these are the common applications of industry 4.0, and we can see all these in real world if industry 4.0 is implemented in the full-fledged in the upcoming years. Finally, we have come down to the challenges that industry 4.0 is facing right now. So the challenges of industry 4.0 are IT security issues, which are demanding to open up the previously closed production shops. Then reliability and stability needed for critical machine-to-machine communication, need to maintain the integrity of production processes, need to avoid any IT snags as those would cause expensive production outages, lack of adequate skill sets to expedite the march towards fourth industrial revolution, general reluctance to change the stakeholders, loss of many jobs to automatic processes and IT controlled processes, especially for the lower educated parts of the society, low top management commitment, unclear legal issues and data security, unclear economic benefits or excessive investment, insufficient qualification of employees, and lack of regulation, standards and forms of certifications. So these are the challenges that industry 4.0 is facing currently. So let's see how many years it takes to be implemented in the full-fledged. That was all for this video, guys. Thank you for watching it. Stay tuned to my channel for upcoming videos. Hit the like if you like this video. Share it among your friends, and don't forget to subscribe to my channel if you are new to this channel. So thank you.